Dana's flying a kite to which an angle of elevation is 70 degrees. The string on the kite is 65 meters long. How far is the kite above the ground? The first thing you need to do in these problems, if you're scared of them, step one, draw a picture. Put yourself in the situation and just draw a picture. The picture needs to include a right triangle. So you're Dana. You're out in a field somewhere flying a kite. Okay? There's Dana. When you fly a kite, the kite is not directly above your head. That wouldn't be very fun. Okay? So, and I said it has to be a right triangle. So you complete your right triangle. The length of the string is 65 meters. And they say the angle of elevation from the ground, 70 degrees. Okay? That's step one. Don't get ahead of yourself. Just draw your picture first, then relax. The question is, how far is the kite above the ground? So we're looking for the height of the kite. When you measure the height of something, that is vertical from the object straight down to the ground. So we're looking for that. If you are struggling with what trig function to use, and that is a common struggle, figure out which side of the triangle we don't care about. Okay, so looking at the picture, not even by name, just look at the picture and figure out which side we don't care about. All right, and looking at this, it looks to me like this is the side that we don't care about. So then what you have to do is figure out which side that is. And if you're standing at 70, it's not the hypotenuse, and it's not the side opposite 70. That's the x. So this is the adjacent side. So we don't care about adjacent, which is a. So the trig function you should select is the trigonometric function that does not have a. So pick the one that just has O and H, and that is sine. That's right. Okay? So that's about as basic as I can make the explanation. Find the side that you don't care about and pick the trig function that also doesn't care about it. Sine. And when you take the sine of something, you're taking the sine of an angle. The sine of the angle is opposite, x, over hypotenuse, 65. We want to get the x by itself. It's x divided by 65. So we are going to multiply by 65. We get x equals 65 sine 70. That becomes a calculator problem, 65 times the sine of 70. Just looking at it, I know the answer is going to be less than 65 because Mr. Glass taught me that the hypotenuse is the longest side of a triangle. Right triangle. So the answer is, using my calculator, 61.1. If you went to the nearest meter, that's fine. 61 meters. Okay. Draw a picture. Relax. Figure out what they're asking. Put in a variable. Figure out the trig function. Then just do the ratio and some algebra. Let's try another one. Got squirrels dropping nuts. going to let you try this one, but I will give you one piece of information because I think this problem is kind of confusing. They say the nut drops 15 feet vertically. That to me means the squirrel is 15 feet up in the tree. Okay? So see if you can draw your picture and solve the problem. And then we'll go through it step by step in a couple minutes. Let's talk picture. There's my picture. My squirrel looks like a cat. I believe so because, in my opinion, we don't care about this side. And that side is the hypotenuse. Regardless of where you're standing, the side opposite the 90-degree angle is the hypotenuse. The angled side, or whatever you want to call it, is the hypotenuse. There's no getting around it. It doesn't change depending on where you're standing. The hypotenuse is the hypotenuse. Okay? So we need the trigonometric function that does not have an h in its ratio. And that would be the tangent. So we're going to set up a ratio that has tangent of 17 is opposite x over adjacent 15. We want the x by itself, so we would multiply both sides by 15, and that's a calculator question, and you get approximately 4.5 feet. Okay, so here's my triangle labeled. 100-degree, 100-foot tall pole, 150-foot rope. The rope is 150 foot long. It doesn't say it's 150 feet from the pole to the stake or anything like that. It says the rope itself, 150 foot long. So you have to picture the situation in your head. The rope is up there in the air, not on the ground. And we want to know that angle. So, same thing. What side don't we care about? This dude down here. And what side is that from x's perspective? Adjacent, because it's next door. So we want to use the trigonometric function that does not have an a. That would be sine. So we would set up sine of x is 100 over 150. What we talked about yesterday was when we're looking for an angle, the way we move that sine to the other side to get the x by itself when we're looking for an angle is we use inverse sine. You can reduce the 100 over 150 if you want to. It's 2/3. Or you could just leave it 100 over 150. So you're going to take the inverse sine. That's what you do when you're looking for an angle. And you get 42 degrees. To the nearest degree is fine. So we're actually finding that x down at the bottom by the boat. That's going to be our answer. The angle of depression is from the eyes up there at the top looking down. The numbers look like that. The side that we don't care about, the frown side, right there, which is the hypotenuse. So we want the trigonometric function that does not have an h in its ratio. That would be tangent. So our trigonometric ratio is the tangent of x is 200 over 175. We're looking for an angle. which means we're going to have to use the inverse tangent. So we throw that tangent over to the other side. When you flip it over to the other side, it becomes the inverse. And that is, to the nearest degree, 49 degrees.